Hi guys, welcome back here at the Easy Engineering Tutorial. So this will be the last part ng design of drainage canal. So punta tayo dito sa typical steps in canal design. Okay, so first is you must know the following parameters. Number one is yung area to be irrigated in hectares. So it is for irrigation canal. No? Number two is the water duty. So for clay, we have 1.5 liters per second per hectares, and for sandy soil, we have the water duty of 2 liters per second per hectares. So if we say water duty, this is defined as the area irrigated by a unit discharge of the water flowing continuously for the duration of the base period of the crop. So, and if we talk about base period or the crop period, it is the time between the first watering of a crop at the time of its sowing to its last watering before the harvesting. Okay, so third is the roughness coefficient. So for earthline canal, for main canals and laterals, we use n equals 0.025. For earthline canal, for farm ditches, yung ginagamit natin is 0.030. And for drainage canals, we have 0.04. And for concrete line canal, we use 0.015 to 0.018. And for HDPE pipe, we use 0.01. So, fourth variable is the side slope, no? So, pag clay yung soil, yung ginagamit natin for main canals and laterals is 1.5 is to 1 for side slope, and for farm ditches, 1 is to 1. And for sandy soil, we use side slope na 2 is to 1. And for concrete line canal, we use the following side slope. No, we have 1.5 is to 1, 1 is to 1, and 0 is to 1. Okay, so next is okay, so next is the B over D ratio, or we designate it as M. So for earthline canal, we have these following values, no? So pag yung discharge natin is less than 0.10, so yung M na gagamitin natin or yung B over D is just equal to 1. Pag in between siya ng 0.10 and 1.5, yung M natin must be 2. Pag in between siya ng 1.5 tsaka 4, yung M natin is 2.5. Tsaka pag greater than 4, yung M natin is 3. So for concrete line canal, so yung M natin is 0.6. Pag yung side slope is 1.5 is to 1. 0.85 pag yung side slope is 1 is to 1. And M equals to pag yung side slope is 0 is to 1. Okay, so next na gagawin natin is we need to compute for the required discharge. So meron tayong formula for that. That is just equal to the area multiplied by the water duty divided by 1,000. And we need to determine the desired slope S for our canal profile. So we have water surface gradient, so which is equal to the water surface elevation A minus water surface elevation B over the distance AB. So yung minimum slope is S equal to 0.0025. So compute the water depth. So we have this formula. So we can also derive this one using Manning's formula. So anyway, for side slope na 1.5 is to 1, or tsaka yung M equals to, for earthline canal, yung depth natin is just Qn raised to the power of 38 all over 2.558 S raised to the power of 1 half. and so on and so forth. For concrete line canal, whose side slope is 1 is to 1 and side slope is 0 is to 1, ito naman yung gagamitin natin ng mga formulas. So, note yung D dito shall be rounded to the nearest centimeter. For fifth is to compute the canal base, B. So, using the B over D ratio. So, we have this formula. And number 6 is to compute for the area of canal, the weighted perimeter, the hydraulic radius of the canal prism. So, again, we have this formula for area in function of side slope, for perimeter in function of side slope, and the hydraulic radius, which is the ratio of area over perimeter. Next is we need to compute for the canal velocity in meter per second. So we have this formula from Manning, naka SI units. And we need to compute for the supplied discharge yung QS in cubic meter per second. So using the continuity equation, area times velocity. So yung QS shall be approximately be equal to the QR with allowable of plus minus 0.005. So dapat yung supplied discharge natin, as much as possible, mag-equal siya doon sa required discharge natin. Okay, so next is we need to compute for the depth and the value of t natin. So we have the d, which is equal to d plus 0.3 as a minimum, and 1.4 times the depth. Ito yung 40% increase ng water depth natin. So for pre-board. And sa top burn natin, yung minimum is 0.6 meter. We can use this one. We have equivalent to D. Okay, so next is, I think this is example na. Okay, so the last step is to write the canal elements. So parang ganito. Okay, so we have the discharge velocity, area, the bottom width, the depth, the overall depth, the top width, the hydraulic radius, the gradient slope, or the bed slope, the side slope, and the roughness coefficient, and computation for canal elements. Okay, so given yung water duty natin na 1.5 liters per second per hectare, so bali clay yung soil natin, and then meron tayong side slope na 1.5 is to 1, bali earthline canal. So yung cross-sectional area, designated area is 160 hectares. So meron tayong meron tayong bed slope na 0.004, So meron tayong area na 160 hectares and a desired canal slope na 0.0004. So first is we need to compute for the required discharge, yung QR. We have the formula area times the water duty divided by 1,000. So we have a area of 160 hectares multiplied by the water duty na 1.5 divided by 1,000. So yung required discharge natin is 0.24 cubic meter per second. So bali, since yung flow rate natin is in between ng 0.10 to 1.5, therefore yung B over D ratio na gagamitin natin for earthline canal is equal to 2. Bali yung B natin is 2D. Okay, so we need to solve for the depth of our water, so using this formula. So we have this weighted area, which is B plus 1.5, the side slope, multiplied by the depth, multiplied by the depth. And then we have the weighted perimeter, which is B plus 2 times the depth times 1 squared plus 1.5 squared. 1.5 is yung side slope, raised to the power of 1/2. So we have B equals B plus 3.6, the depth. We need to substitute yung value natin na B over D equals 2. So bali yung B equals 2D. Substituting that, we have area now nga 3.5 d squared and perimeter na 5.6 d. So we can now solve for the hydraulic radius in function of the depth. So we have 0.625 of the depth. So from the formula of Manning, so we have this velocity formula, 1 over n r 2/3 s 1/2. So we just need to substitute the value of our hydraulic radius and side slope. So okay, so from the formula for the discharge Q, so meron tayong formula. We have this one. So area times velocity, we just need to substitute yung velocity natin kanina to compute for the value of D. So bali ito na yan, no? So we just need to substitute the value of Q, the value of N, and the value of slope. Okay? So we have the depth na 0.45 meters. So bali mako-compute din natin yung canal base natin, which is 0.9 meters. And we can also compute for the area and the weighted perimeter. And also we can compute for the hydraulic radius, which is 0.281. And we can now compute for the velocity, which is 0.343 meter per second. So we can also compute for the supply discharge yung QS. So we have 0.243 cubics. So that's okay, no? So we can also compute for the value of D, which is 0.8 meters. And we can compute for the top burn, which is 0.8 meters. So yung canal element natin is ito na yan. Okay? As a summary. So, bale, dito sa cross-section natin, so ito lang yung kinumpute natin, yung area na 160. So, kung meron ka pang area dito na 140, dito is 180. So, parang ganito yung mangyayari. Okay? So, bale ito yung sa water surface natin. And, ito yung mga canal elements nila. So, we have this profile for canal bottom and profile for top bank. Okay? So, yan na. Okay, so, bali ito yung topographic chart, topographic map nung project natin. And, so, ito lang yung shaded, yun yung consider natin sa design. So, ito naman yung total construction cost for equipment and labor. Okay, so next is design of irrigation canal system. So, bali yung given naman dito is ito, no? So, meron tayong water requirement for 80 hectares of banana farm. So, which is 8 mm per day. Okay? So, kung may water requirement tayo na 8 mm per day. So, we use the trapezoidal earth canal with a slope of 3%. Rock cut, smooth and uniform. So, meaning yung N natin is 0.025. We have a side slope of 3:1. We have M or the B over D ratio, which is 0.5. So yung distance between the source and the farm is 3,000 meters. And the source of water contains unlimited supply, the river system. And the losses due to delivery is 20 liters per second, including evaporation loss, seepage loss, and other losses. And losses due to delivery is 22.69 liters per second. And we have this flow rate, which is 4 cubic meter per second. And assume all necessary data with justification. Okay, so the first step is we need to compute for the dimension of canal using this formula. We have D, which is equal to K, and K is constant, which is equivalent to 0.143 multiplied by the flow rate raised to the power of 38 all over the canal slope raised to the power of 3 over 16. We just need to substitute yung value natin for K, Q, and S. So we got the value for the depth, which is 0.464 meters. So for best hydraulic cross-section, we use this formula, no? B equals twice nung depth tangent theta divided by 2. So, since given yung side slope natin na 3 is to 1, so therefore, yung tangent theta natin is just equal to 1/3. No? Thus, if you solve for theta, theta is 18.43 degrees. We just need to substitute the value of the depth that we compute earlier and also the theta. So, like, we have now the canal base, which is 0.151 meters. So, we can now compute for the value of D, which is D plus the freeboard, that is 0.664 meter. We can now compute for the area, perimeter, and hydraulic radius, which is 0.716 square meter, 3.09 meter, and 0.232 meter, respectively. So, summarizing the dimension, we have this one, and ito naman yung cross-section niya. Okay? So, we have also computed the total cost of construction for materials and labor. So, another example is yung water requirement for 90 hectares of farm is 7.6 millimeter per day. Again, trapezoidal earth canal is to be used with a slope of 3%. Yung roughness coefficient is 0.04 with a side slope is 3 to 1. And then we have B over D na 0.5. The distance between the source and the farm is 2,000 meters. The source of water contains unlimited supply. The losses due to delivery is 22.69 liters. Irrigation period is 8 hours per day with a flow rate of 3 cubic meter per second, and assume all necessary data with justification. So the requirement is to compute for the dimension of canal, the total cost of construction, and also the complete details of canal section. So for the dimension of canals, again, we use the same formula kanina. Like, we just need to substitute the value of K, which is 0.143. Yung flow rate is given, we have 3 cubic meter per second, and also the canal slope is also given, which is 0.03. So computing for the depth, we have 0.416 meters. And ayan na. For best hydraulic cross-section, we use again the same formula, which is 2 times the depth tangent theta. So since given yung side slope natin na 3 is to 1, thus yung theta is 18.43. And with that, we can compute for the canal base, which is 0.135. So summarizing, we can also compute the depth, which is D plus the freeboard, the area, the weighted perimeter, and the hydraulic radius, respectively, as shown here. And summarizing all the canal dimension, we have this one, and we have this cross-sectional details niya. And we have also the, yun lang pala yan. Okay? So, I think that's it, no? That's it for the typical design of canal. Okay, so I think that conclude for the design of drainage channel. And yeah, continue watching dito sa DEC Engineering Tutorials. Thank you.